Welcome to my video on Euler's method and logistic growth. In this video, I'm just going to be going over the concepts. You'll probably be using this for review. I don't think that you'd necessarily be using this as like trying to learn the concept. It could definitely help you learn the concept, and I'll definitely treat it like that. But I would assume at this point that you know the concepts, as well as the fact that these are some of the easier concepts in Calculus BC, and I don't think people usually have as much trouble with them. They're a lot more simple to understand. So the way I'm going to structure the video is to go over the conceptual understanding of each concept, and then to do a practice problem on each. And then we'll end it with misconceptions and common errors. So Euler's method, really simple. All it does is tells us how to extrapolate the y value of a certain point, given an initial point, a slope, or like a slope function, and that's the only two things that we need. So the idea is to create multiple tangent lines that mirror a curve like this, and that will be able to predict where the y value of a point on the curve is. So as you can see, there is some error in it. It's an approximation, but the more lines that you use, the closer you would get to the actual curve, right? Just imagine that, like, using more lines, you get a more curve-like shape. So let's get into the practice problem. Before we do that, though, there's some simple terminology. It's just that h is step size, and I'll get into more of what step size is in the practice problem. So the practice problem says approximate y sub 3 when the slope function is y plus 4x, and h is equal to 0.5, so our step size is 0.5, and they give us the initial point 2, comma 2. The step size just tells us the distance, the x distance between our our tangent lines, so like how long each of our tangent lines can be in the x direction. In this case, since we're going from 2 to 3 on the x-axis, we're going to want two tangent lines, each of which are 0.5 long on the x-axis. So we just plug that into here, so 2 plus 10, or 2 plus 8, so y is equal to 10x. And then you solve for b, so minus 18. Once you've got that down, you just try to figure out the next point. So the idea is to go from the x value of 2 to the x value of 2.5, and then to create a new tangent line to go to 3. So in order to find the approximation of the y value at 2.5, at x equals 2.5, we just plug in 2.5 into this equation, and that gives us 7, because 2.5 times 10 is 25, minus 18 is 7. Now that we've got that, we've got to create another tangent line. And so you just plug that into this slope equation. That gives you y is equal to 17x plus our b. And to find b, we just obviously plug in our value. So 2.5 times 17. And then or is equal to 7, so minus 7. So then our b value is going, our b value is going to be minus 35.5. And then once we've got there, it's just a simple manner of plugging in 3. So y sub 3 is equal to 17 times 3 minus 35.5, which gives us the value 15.5. So as you can see, it's really simple. It's just plugging in numbers, just crunching numbers, and I don't think it's extremely complicated to understand. I'll go over some misconceptions, so stay around for that. I'll do that at the end of the video. And I think that if you just practice these problems a lot, you'll become like an ace at them. So if you want some more practice, you could look at the quiz that me and my group made and the worksheet that me and my group made. There's also keys there. So that should definitely help you. And so let's go on to logistic growth. Logistic growth is a lot easier than it seems. It's just a couple formulas. So this formula, and then this formula. And this just helps us figure out A for the piece of t formula. This first formula tells us the change in population. So this dp over dt is the change in population. And r is the rate at which the population changes. So sometimes it's denoted as lowercase k. R, lowercase k, same thing. The book might use lowercase k, so keep your eyes out for that. P is our population, which is a variable, and then k is the carrying capacity. So if you look over here, a logistic growth model will always have this S-shaped curve. And what carrying capacity is, it's the amount of population a certain environment can hold. is able to sustain. So that's the max amount of population that can exist in that environment. That's the max amount of population we would ever see. It always goes. The population should steadily remain underneath that carrying capacity. And so the idea is just to understand the relationships between all these variables, and then figuring out the problems and understanding how to apply your knowledge to the word problems that you face. So r/k is the rate, p is population, dp over dt is the change in population, k is the carrying capacity, if that helps you remember it. I know Mr. Happ did it like that. And then p naught's the initial population. So hopefully, if you understand this terminology, you'll be able to figure out how to utilize the stuff that you get in the word problems to solve these the problems using these relationships between the variables. So I wrote out all the equations here, but you're gonna have to memorize them for the final and for any test you do, I would assume. Suppose a population grows according to a logistic growth model, and the carrying capacity is 3,000, and lowercase k is equal to 0.005. A says write the logistic growth equation. That's just this thing over here. So 0.005, and over here I know in the picture that the p is over here. I personally prefer to move it over here just because that's easier to see for me. So p is our variable here, so we leave it as p, right? Because the population is the thing that changes, whereas our carrying capacity and our rate of growth should not change unless they say that the rate of growth changes or something, or the rate of change of the population changes. So yeah, that's our logistic growth equation, pretty easy. If the initial population is 500, write a formula for the population after t years. Initial population is our p naught, right? So that and when it says write a formula for the population after t years, it wants this thing. So let's start writing it. P sub t is equal to k, our carrying capacity, uppercase k, so 3,000, over 1 plus ae to the negative rt. Now we gotta find a, right? So a is just equal to 3,000, our carrying capacity minus our initial population of 500, all divided by 500, which should give us 5, right? Because that's just 2,500 divided by 500, so that's 5. Therefore, we can put a 5 there. E to the negative 0.005 t. That's it. Because t is our variable again here, because it wants a formula for the population after t years, and we're finding piece of t, right? Then it says find the population for 10 years. That's easy. You just do piece of 10. So in your calculator, one thing you've got to be careful about is making sure you don't like multiply or like add or subtract when you shouldn't be, like PEMDAS basically is what I'm saying, because it's kind of hard to get that confused in this type of question. So 0.005 times our p is 10 in years. So yeah, just plug that into your equation. And so I just did it on my calculator, and it gave me a syntax error, which probably means, like, this is just what I'm saying, like, in your calculator, like, when you're doing it, you've got to be careful to follow PEMDAS, because, like, that can easily screw up your answer, and obviously it just did for me. And so I got it right this time, and it told me that my population at 10 years is 521.18, and usually you want to round that up, because you won't have like half a person or part of a person. So your population is probably 522, unless it says to like 2 decimal places or something. You can get that clarified with your teacher. The multiple choice is multiple choice, obviously, or the final's multiple choice, so you shouldn't have trouble there. But if it's like an FRQ or something, go ahead and talk to your teacher. Go and ask Mr. Happ, like, do you want this rounded? Do you want us to leave it in decimal? Teachers have different expectations. So now we can do misconceptions. One thing to note before we do misconceptions is that the concepts that I taught are not that difficult to understand, and the idea behind them is just to simply understand the relationships between all the variables and the things in the equation and how those work together. And then you'll be able to apply your knowledge to any type of word problem. Like, I know there are multiple different types of word problems, and obviously the problem I showed you isn't not going to be the only type that you see, but hopefully you'll be able to use the knowledge, like if you truly understand it, to apply that to other problems. And I think that once you get it, it should be really easy to understand. The first thing is, in logistic growth, make sure you know the difference between lowercase k and uppercase k. Uppercase k is your carrying capacity, and lowercase k is the rate at which the population changes. So just keep that in mind because that's really easy to confuse. Also keep in mind that it's e to the negative rt. Like, a ton of people forget the negative sign and then they get really messed up. And again, like I was talking about, make sure you plug it into your calculator correctly and adhere to the rules of PEMDAS, because you can get like drastically different answers. And then also with step size, some people have some trouble like understanding how many steps to do. Like, when it gives you the step size, like they think, oh, step size is 2, that means do 2 steps. That's not true. It's telling you the x length. It's telling you how long it should be in the x direction. So if you're going from a point at x is equal to 7 and to a point that x is equal to 9, for example, and it tells you your step size is 1, that doesn't mean just do one tangent line from 7 to 9. It means do tangent lines that are the length of 1 on the x-axis. So x equals 7 to x equals 8, that's one tangent line. X equals 8 to x equals 9 is another tangent line, so we'll have 2 tangent lines. So that's just something to keep in mind. Also, step size is h. They might just say h, that's step size. And hopefully this video really helped you. The concepts aren't too difficult to understand. I'd say the best way to master these concepts is to just do a ton of practice problems. In that way, you'd get exposed to a different ton of scenarios, like different things that they might ask you, and you could also just like make less mistakes when you're actually doing it on the test because you're so used to it, right? I would also recommend double checking your work for these problems because it's so easy to make mistakes. And on multiple choice, you know, if you make a mistake, like you lose like that 2% or 4% or whatever it's worth of your grade. So you got to be really careful there. Thanks for watching.